Alright, here's the first video for binomial distributions and how to use it. For this one, we'll set it up as if we were doing this without a calculator, but some of the calculations we will need a calculator for. So in a multiple choice test, there are 10 questions. Each question has 5 choices, one of which is correct. 70% is the pass mark, and if someone, Raj in this case, is going to guess completely random guesses on each one, we want to know what is the chance he passes. So a few things to keep in mind here. First, the probability of a success. In this case, getting a question right. Well, if there are 5 choices and one of them is correct, he has a 1 in 5 chance to get it correct. N is how many total experiments we have, and in this case we have 10 questions, so N is 10. Now of those 10, we need to think how many do we want to get right. Well, he needs 70%, so we will say R would be 7 questions right. 8 questions would also work, 9 questions would also work, or if he got all of them right, that would also be a passing mark. If he got 6, 5, 4, 3, 2, 1, or 0, he would not pass, so we don't care about those. So we're going to set up 7 first, and then we're going to switch to a calculator. So to set up 7, it's N and R, then times 1/5 to the R power. We want 7, right? So 7th power times the chance of a failure, which in this case is 4 out of 5. And we want, if he's getting 7 right, that means we have 3 failures. And we would do that on a calculator and get something. Okay, now you can probably see that doing this equation 1, 2, 3 more times and then adding all 4 together is not the best way, so we're going to switch to using a calculator. So on my calculator, I'm going to hit second and distribution. That brings me to the distributions, and we're going to find binom CDF, which is towards the bottom. Now we're using CDF because we have a range of values that we want. We want 7, 8, 9, and 10. If we had one value, we just wanted 7, we would use binom PDF, but in this case CDF. In trials, I'm going to put 10. The p-value, as I said, is 1/5, so 0.2, or 1/5. The x-value, now with CDF, remember, so if this was at 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, or 10. That's all that can happen to Raj. He can get 0 right, or 1 right, or 2, or 3, or 4, up to all 10 right. Nothing else can happen. What we want is 7, 8, 9, and 10, the passing marks. What our calculator can do with CDF is add a number and below. So for this one, we want to put 6 for our x value. And what that calculator is going to do then is calculate the chance of him getting 6 right, and 5 right, and 4 right, and 3, and 2, and 1, and 0, and add all those together. What it gives us is 0.9991. More decimals, but we'll just take that many. That 0.9991 represents everything we don't want. We don't want him to get 6, 5, 4, 3, 2, 1, or 0 right. The good thing is that is the whole of all we don't want. So all we'll need to do is take 1 minus this, and we get 0.0008. So in other words, he has a very poor chance to pass, which if we think about that logically, if you're going to have a multiple choice test of 10 questions, 5 answers each, and you need to get 70%, you would not expect to pass just by random guesses. So that is binomial. In this case, CDF on our calculator is the best way.